Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about construction of minimum spanning trees through Kruskal's and Prim's algorithm. So, very first thing is that what is the minimum spanning tree first? So, spanning tree is nothing but a connected graph. So, whose vertex set should be same as the vertex set of the given graph, and whose edge set is also a subset of the edge of the given graph. So the weight of the spanning tree is nothing but the sum of all the edges in the tree, and minimum spanning tree is the spanning tree with the smallest possible weight. Suppose if I'm going to be construct a graph G. So here what I'm going to say that spanning tree is nothing but a graph. So whose vertex set and then edge set should be same here. But only thing is that have to be find out the maximum or smallest possible weight of that graph. So if I'm going to have the graph like this, so what are the possibilities of obtaining the spanning trees is that A, B, C, D, and some other form is that A, B, C, D, and some other span form of the spanning tree should be like this. So these are the various possible spanning trees. So, but only the best thing how can I do to obtain is that the minimum spanning tree is the spanning tree with smallest possible weight here. And how can I able to find the weight of the spanning tree is nothing but the sum of the weights of all edges in the tree is nothing but the weight of the spanning tree. Suppose this is the graph we are going to have. So in this graph, what I'm going to say that these are the many possible solutions of spanning trees from the given graph. And if I'm going to have the weighted graph, then how can I able to construct the minimum weight spanning tree here? So for that, I have to be construct the spanning tree by making use of minimum weights to be identified, and some of all the weights should be the cost of the spanning tree. That should be 1 plus 2 plus 3, that should be 6. So the minimum weight minimum cost spanning tree is that 6. So this should be the obtaining the spanning tree in case of weighted graph. So for this construction of this spanning trees, we are going to have two types of algorithms like Kruskal's algorithms and Prim's algorithm. So both algorithms are going to be different in methodology, but where the Kruskal's algorithm is going to be used the edges as the concept, and whereas the Prim's algorithm is going to be used the vertex connections here. So in Prim's algorithm, at any instance of output, it represents the tree. So whereas in Kruskal's algorithm, at any instance of output, you should able to represent tree or not. So in both the algorithms, mm, we're going to find out the minimum spanning tree, but the methodology is going to be different here in Kruskal's and Prim's algorithms. So in Kruskal's algorithm, we're going to be use the edges here, whereas in Prim's algorithm, we're going to be use vertex connections here. So in Prim's algorithm, so any instance of output is going to represent the tree, whereas in Kruskal's algorithm, at any instance of output, it may also represent the tree or may not be a tree. So comes to the first one, that is Kruskal's algorithm. So Kruskal's algorithm is nothing but a greedy algorithm, which is going to be choose some local optimum. So that is nothing but the picking edge with the least weight in the spanning tree. So how this Kruskal's algorithm is going to work here? So take a graph with n number of vertices and then keep on adding the shortest edge, and by avoiding this creation of cycles. So until n minus 1 edges is going to be added here. So the Kruskal's algorithm, so take a graph with n vertices and keep on adding the uh, least cost edge. So while avoiding the creation of cycles, so until n minus 1 edges has been added. So sometimes two or more edges have the same cost, and the order in which the edges are chosen. So in this case doesn't matter, but the different spanning tree may able to result, but they will have the same total cost, which always be the minimum cost here. So this is the algorithm where can able to uh, construct the spanning tree by using Kruskal algorithm. So here we can able to make a tree here and should be as empty and repeat this steps 3, 4, 5 as long as the tree contain n minus 1 edges and E is not empty, otherwise can able to proceed to the step 6. So choose an edge from the edge set of the lowest cost and then have to be delete from the edge set, and if that edge does not create a cycle then add it to the tree, otherwise can able to discard the edge. So if the tree contains n minus 1 edges, then you can able to print uh, the spanning tree. So how this Kruskal algorithm works? So initially how to construct a tree. Okay, this is the graph we are going to have. So in this, what I have to do, I have to choose the edge. So the edges may be AB, BC, CD, and AB. So AB is 1, AD is 2, BC is 5, CD is 4, and BD is 3. So how to be construct the spanning tree in such a way that we have to be uh, select the minimum cost first. So A, B, C, and D. So first we have to choose the minimum cost one, that should be 1, and BC, that should be, so next minimum cost is 2, that's why I'm going to select AD, and next minimum cost BD, but it is going to form the cycle, so that's why I'm not going to be select this, and CD, I'm going to select BC, it is going to form the cycle, so this is the minimum spanning tree that is obtained from the given graph according to Kruskal algorithm. So here is the problem we're going to have. So the vertex represent 8 regional data centers, which is need to be connected with high-speed data lines. And the feasibility study showed that the links illustrated as possible, as above as possible, and the cost in millions of dollars showed the next to the link. And which link should be constructed to enable the full communication and keep the total cost minimum. So this is the problem we are going to be faced. So how can I able to solve this problem by making use of this crystals and then Prim's algorithm, that is spanning tree. So the problem is that we are going to have the vertices and different cities, which is going to have 8 regional data centers. So which is going to be connected with high speed lines, and cost of this high speed line should be in the form of millions of dollars. So how can I able to do that? Uh, which link should be enabled in order to make the full communication and keep the total cost should be minimum. And so this is the final output of this problem. So how can I able to construct this? I can able to explain now. So here what I'm going to say. So this is the you can able to select this and all the lines, fully connected lines to make the city, and the overall cost should be 427 billion dollars like this. So for that, I'm going to make use of this Kruskal algorithm. So given connected graph with non-weighted weights of edges, so for that I'm going to find first the spanning tree. So it should be the sum of the weights of edges in the tree as small as possible. So for this, I'm going to use Kruskal's algorithm. So while constructing this Kruskal's algorithm, you have to be avoid the cycles first. And for that, what I'm going to do, we have to be first sort the edges by weight, and build the spanning forest by adding on the minimum weight, and which then added to those already chosen that does not form the cycle. So Kruskal's algorithm, so going to be sort the edges by 8 and then build the spanning tree by keep on adding the minimum weight to the graph, and which in turn add the another weight which does not form the cycle. This is the procedure for constructing this spanning tree. So among this entire graph, so first of all, what I'm going to say is, so I'm going to identify the minimum edge. So I'm going to identify first. So for that 23 is the minimum. So I'm going to select this edge first in first step. And the next step, I'm going to select the next minimum edge from the graph, that is 29. So I'm going to select this. And next step, what I'm going to select this is 31. So 31 is going to be selected. And next minimum edge is how much? 32. So 32 is going to be selected. And next minimum edge, what I'm going to identify is 47. So 47 is going to be selected. And next minimum edge is 54. So 54 is selected. And then so next minimum is 55. So if I'm going to select this 55, it is going to form the cycle here. So that's why what I'm going to say is it is going to form the cycle. So that's why I'm not going to be select this edge. And next minimum cost is 68. So if I'm going to select this also, it is going to form the cycle. That's why I'm not going to select this. And if I'm going to select this one also, it is going to form the cycle. And if I'm going to select this, this is also going to form the cycle. So the weight of the spanning tree should be 23 plus 29 plus 31, 32, 47, 54, and then 66. And this should be the total minimum cost of this. So initial solution is this. So which is going to be roughly cost around $427. So in order to minimize that, so I have applied the Kruskal algorithm. So for the construction of spanning tree, so that one is going to apply, and finally I can able to get only $282. So that is the best approach for finding this solution to the problem. And next one is that Prim's algorithm. So Prim's algorithm also a famous greedy algorithm, which is going to be used to find the spanning tree for the given graph. So to apply this algorithm, so the given graph must be weighted and then connected and undirected. Okay. So in the spanning tree algorithm, any vertex not in the tree but connected to it by an edge can be added. So to find the minimum cost spanning tree, we must be selective and we must always add a new vertex for which the cost of new edge should be as small as possible. And simplified modified algorithm in spanning tree is called Prim's algorithm for finding the minimum cost spanning tree. So the Prim's algorithm also follows this greedy algorithm, and mainly this one is going to be used for finding the spanning tree. In order to apply this Prim's algorithm, so the graph must be weighted, connected, and then undirected only. So in this kind of algorithm, so any vertex not in the tree but connected to an edge can be added. To find the minimum cost spanning tree, we must select two, and we must be always adding new vertex from which the cost of new edge is as small as possible. So here we have to be construct the tree first. So for that, what I'm going to have to select the one vertex at a time, and then start to retrieve one point tree, then add the edge of the minimum weight among those whose endpoint is tree, otherwise not in tree. So build a tree one vertex at a time and start with one trivial point and add an edge of minimum weight with one point other than not in tree. So for this, what is the algorithm for implementing this Prim's algorithm? So in this Prim's algorithm, you have to be randomly choose one vertex, and the vertex connecting to the edge have at least weight that is usually selected. And then second step, we have to be find all edges that not connect the tree to the new vertices. Find the least weight edge among those and include it in the existing tree. If including the edge is going to create the cycle, then reject that edge is look forward to the next minimum weight edge. And keep on repeating the steps to until the vertices are going to be included in the minimum spanning tree that is going to be obtained. Okay, so what I'm going to say, so for the given graphs you have to be select an edge, so that is going to be least one, and then you have to be successfully find the next edge from the and find it out for any including edge is going to form the cycle, then reject the edge and look forward to the next edge, and keep on repeating these steps until all the edges, all the vertices in the graph should be the spanning tree. So for this given graph, so initially I'm going to be start from the vertex one. So from this I'm going to select what is the next minimum edge of the graph. So here normally what I'm going to say. So here, so what are the possible halves? 75 is there, 88, 55, and then 32. So among this all the edges, I have to find out the next minimum edge. What is this? That is 23. So I'm going to select 23 is the edge. So from here onwards, again I have to find what is the next minimum edge that is going to be selected. So for that I'm going to select 32. Why? Because from here I have the 93 and then 80 and 32 is there. So 32 is minimum. So from this place I'm going to select the next minimum. And from this I have to find whether 31 next to 55, 79, 74 is there. So among those, what is the next minimum? That should be 31. So 31 is going to be selected. So like this I have to be followed here. And then from here, what I'm going to say, if I'm going to next minimum is 74, 88, and 29 is there. So 29 is minimum one. So I'm going to select this 29 first. And from here, I'm going to say what is the next minimum I have to be done. So for that, what I'm going to do. Uh, So from here, what is the next minimum? 79. So if I'm going 68 is there. So if I'm going to select 68, so if I'm going to select 68, it is going to be from the cycle. So that's why I'm going to be reject. Right. I'm going to select it. So what happened? This cycle is going to be formed closed one. So I'm going to be rejected. So what is the minimum cost here? So 23 plus 29, 31, 32 plus 54, and then finally 66. And this one, so what I'm going finally the computational problems that is going to be occurred in Pulse and then Kruskal is that is going to be required the sorting edges by weight and the preliminary step. So this is the one of the drawback of this Prim's algorithm, Kruskal's algorithm. And similarly for finding for implementing this Prim's algorithm, we keep on tracking the edges of the minimum weight with one endpoint in the component, and the both components are going to be changed. How does one do this? So this one should be the difficult or drawback of this Prim's algorithm. So Driscoll's algorithm, so have to be sorting the edges by weight as the primary step, and in Prim's algorithm we have to be keep on tracking the edges of minimum weight with one endpoint in the component. That is the drawback of this Prim's algorithm. So that should be about the construction of this minimum spanning trees. So minimum spanning tree is nothing but a graph where the possibility of all the vertices in the graph should be minimum. So for the undirected graph, we are going to be construct many possible spanning trees. When it comes to weighted graph, we have to be find out the minimum cost of that graph should be the spanning tree. So for implementing these minimum spanning trees, So we're going to have two kinds of algorithms. So first one is that Kruskal's algorithm and the Prim's algorithm. So Kruskal's algorithm is going to be use the edges here, whereas the Prim's algorithm is going to be use the vertex connections. And in Prim's algorithm, at any instant of output, it represents the tree, whereas in Kruskal's algorithm, at any instance of output, it may represent the tree or not. So the greedy algorithm always chooses some local optimum and picking a method with least weight in the minimum spanning tree. And the Kruskal algorithm is going to be how it is going to work means. So first of all, you have to be take a graph with n vertices and keep on adding the least first edge, avoiding the creation of cycles. And sometimes these two or more edges should also have the same cost. And this is the algorithm how we're going to be constructed. So if edge does not for construction of this is the algorithm for construction of the spanning tree. So this is the one of the case study I took. So how we're going to solve this networking problem to minimize the cost of this network. So for that, what I'm going to say is that so this is the spanning tree initial of if I'm going to calculate it. So after applying this Kruskal algorithm, so what will happen? It is going to be find out the minimum cost of this network. So finally, to get 282 when compared to the initial one. And the next one is that Prim's algorithm. So Prim's algorithm is also going to follow the algorithm. And in order to apply this Prim's algorithm, the graph should be weighted, connected, and directed. Then we'll have been able to apply the Prim's algorithm. So how this Prim's algorithm will work here is that so all the time you have to take a source vertex. From this vertex, you have to find out the next minimum edge. And again, you have to find out the next minimum edge from that vertex. So that should be the Prim's algorithm. And if any edge is going to form the cycle, then I have to be rejected and then keep on finding the next edge. And this is the way of finding solving the problem according to the Prim's algorithm. And these are some of the computational issues of this Kruskal and Prim's algorithm. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.